All right, for the following exercise, perform the indicated operations. So it looks like here we are multiplying. Remember that parentheses is implied multiplication. So you can do this several ways. I know there's like a box method or table method. I tend to just do this very systematic. So I'm going to start with the first term on that first binomial, and it's a binomial because there are two terms, right? And I'm going to multiply it by the first term in the second. So 3d times 2d. Then I'm going to multiply the first term here in our first polynomial by the second term. So this is going to give me plus 3d times 9. And I typically just leave pluses and then I'll simplify at the end. So then I'm going to move on to the second term in that first polynomial there. So I take my second term, and again I normally just do plus. I'll worry about the negatives in a moment. Negative 5 times the first term in the second, 2d, and then plus, move to my last term, so I do my negative 5 here times the second term in the second, so negative 5 times 9. So again, it's kind of just a systematic way to do it. I do put pluses and then I go back and simplify. So 3d times 2d is going to be 6d squared plus 3d times 9 is going to be 27d plus negative 5 times 2d, so this becomes minus 10d, plus negative 5 times 9, so minus 45. And just like when we add and subtract, we want to combine and simplify. So I'm going to get 6d squared. 27d minus 10d is going to be plus 17d, and then minus 45. So systematically, we take each term in the first polynomial, this one just happens to be a binomial, and multiply it by each term in the second. All right, so let's take a look at another one. And on that previous example, I said you can also use a FOIL technique, which you may have learned at some point, the first, outer, inner, last. But that doesn't really apply when we have three terms, does it? But this method of systematically taking the first term, multiplying by everything in the second polynomial, and then the next term and multiplying by everything in that second polynomial will always work for us. All right, so I'm going to take my 4m, and I'm going to multiply it by my 2m squared, my negative 7, and my 9. So that's kind of my first step. So I'm going to do 4m times 2m squared plus 4m times negative 7m plus 4m times 9. Then I'm going to go back to my second term. So my second term here, the negative 13, I'm going to multiply that by 2m squared, negative 7m, and 9. So this is going to be plus negative 13 times 2m squared plus negative 13 times negative 7m plus negative 13 times 9. You don't have to set it up this way, but notice I kind of line these up here to help us see what's happening. So I'm going to go back and simplify. So this is going to give me 8m cubed plus 4m times negative 7m, so minus 28m squared plus 36m. And then I'm going to go down, keep going, so negative 13 and 2. So this is going to be negative 26m squared plus, right, a negative and a negative, so that negative 13 and the negative 7 is going to give me positive 91m, and then plus negative 13 times a positive 9 is going to give me negative 117. Right? And again, I kind of kept these lined up so you see what's happening, right? So if we simplify, 8m cubed, there's only one m cubed, right? But then I have negative 28 minus 26, so I end up with negative 54m squared. Then I have 36 plus 91, so that's going to be plus 127m, and then there's only one constant term, so minus 117. All right, so again, you can use FOIL, right? Like on that previous example, when we only have two, we have binomial multiply binomial, so only two terms, but that doesn't really work. That kind of breaks down when we have more than two terms, right? So this idea of systematically taking each term in the first polynomial, multiply it by each term in that second polynomial. And if we had three polynomials, we do the same thing. We start with the first two, then we take those two, the result of that, and multiply by the next one.